Hello everyone, welcome to my channel. In this video, we will learn about the high-level data link control protocol. High-level data link control is a protocol designed to support both half-duplex and full-duplex communication over point-to-point and multi-point links. So this protocol will be used in the data link layer, and it supports two types of communication, that is half-duplex and full-duplex communication over the point-to-point and multi-point networks. In the point-to-point network, so we'll having only, so point-to-point is a one-to-one network. That means it acts between only two devices. Whereas multi-point means the connection will be established between multiple number of devices. The configuration and transfer modes of the high-level data link control protocol. The high-level data link control provides two modes of transmission, that is normal response mode (NRM) and asynchronous balanced mode (ABM). So these are the two types of configuration and transfer modes of the high-level data link control protocol. So let us see each of them in detail. The first one is normal response mode (NRM). So there will be one primary station and multiple secondary stations. A primary station can send commands. A secondary station can only respond to that command. And normal response mode is used for both multi-point links and point-to-point links. So here we will see about the NRM in detail in the diagram. So we know that NRM supports both the point-to-point and multi-point links. So that's why there is a point-to-point and multi-point links established between the set of devices. So in the point-to-point links, point-to-point link will be established only between two devices. So it connects to 2 points, so point to point. Okay. So here the primary and secondary devices are communicating with each other such that the primary station can send the commands and the secondary station can only respond to that command. So here in the multi-point links, the primary station is sending the command to the secondary stations. So in the multi-point links, here you can consider the point as a station. So multi-point means there are multiple number of stations. The connection is established among multiple stations. Okay. The primary station is sending the command and the secondary stations are responding for that command. So there are two secondary stations that are responding for the command. The next one is asynchronous balanced mode, that is ABM. The link is point to point and each station can function as a primary and as well as a secondary station. So here in the asynchronous balanced mode, so a station can act as both the primary and secondary station. But in the case of normal response mode, a station can act only as a primary or a secondary. But here a station can act both as a primary or secondary. So that's why it is a combined combination. Okay. So it is primary or secondary. So it can send a command or respond. It can respond to the other station. Similarly here also it is a combined one, a station. It can act as both primary and secondary. So it can give command or it will respond for a station's command. So these are the different configuration and transfer modes of the high-level data link control protocol. So here the communication established is using the full duplex and half duplex communication, right? So here we are applying the full duplex communication, whereas in the case of the NBM, so we are applying the half duplex communication. The primary station will first send the command to the secondary station, and then the secondary station will respond for the command, right? In the normal response mode here, for both the point-to-point and multi-point link, so they are following the half duplex communication, whereas here it is following the full duplex communication. So next one is the frame format of the high-level data link control protocol. So here in the frame format, so whenever a station is sending some data to the another station, so it will be having some particular format, that is the flag, address, control, information, FCS and flag. So like how if you are posting a letter to a person, then it will be having some format, right? From address, to address, and the body of the letter, signature. So it will be having some format. Similarly here, if a station is sending some data to another station, so it will be having some format. That format is called as a frame format. So the starting and ending of the frame will be having a flag followed by some address where the message must reach, and the control information and the SCS. Flag field. It is an 8-bit sequence with a bit pattern 0610 that identifies both beginning and ending of the frame. So here the flag bit consists of 8 bits, 8-bit sequence with a 0610 and 0610 that identifies both the beginning and the ending of the frame. And the next one is the address field. So it contains the address of the secondary station or destination, right? If you are posting a letter to a particular person, then you will fill the address of that person's home address, right? Similarly here it contains the address of secondary station or destination. If primary creates a frame, it contains to address. If secondary creates a frame, it contains from address length. That is 1 byte or more, depends on the network. So next one is the control field. It is used for both the flow control and error control mechanisms. And the information field. It contains the user's data, that actual data that the user wants to transfer to the station. So it contains the user's data or network management information. So here the length can vary from network to network. And the next one is the FCS field, the frame check sequence. FCS means frame check sequence field. So it is used for error detection in the HDLC frame format. It can contain either a 2 or 4 byte ITU-T-CRC, that is cyclic redundancy check. And HDLC defines 3 types of frames. So this is a frame format and it defines 3 types of frames. Okay, that is I frame, U frame and S frame. So the information field is present only in the I and U frames. It is not present in the S frame. So now let us see what are the different types of the frame types in the HDLC. So the first one is the I frame, that is information frame. So I-frames are designed to carry user data from the network layer. They also include flow control and error control information. So here the first bit is 0. So in the control field, the first bit is 0, means the frame is a I-frame. And N of S, the next 3 bits define the sequence number of a frame in the travel. And the next one. So next one is the P by F, that is pole or final. It is a single bit with a dual purpose. So we use the pole when the frame is sent by the primary to the secondary station, and final. So final will be used when the frame is sent by secondary to primary station. And the last one is the N of R. So N of R corresponds to the value of the acknowledgement when piggybacking is used. So this is regarding the information frame. So next one is and the remaining frame format is same. The control information only here varies. So next one is S frames, that is the supervisory frames. Supervisory frames are used for flow and error control mechanisms. So here the code in the control information varies. So the first 2 bits means the frame is in a S frame. The first 2 bits are 1, 0. So it denotes that it is a S frame. So second 2 bits defines 4 bytes of S frames. That is receive ready, receive not ready, reject, selective, reject. So these are the 4 bytes of the S frames. And the P by F, that is the pole or final bits, is same as in the I frame. And the next 3 bits are N of R, that is the acknowledgement or negative acknowledgement value. So next one is U frames. U frames means unnumbered frames. Unnumbered frames are used to exchange session management and control information between connected devices. It is the one used for system management for information. So here the code, the first two bits are 1 that represent the given frame is a U frame, that is the unnumbered frame. So these are the different types of frame types in the HDLC, and the pole are finally same as the remaining frames. The next one is the data transparency. Data field of the HDLC frame can carry text as well as non-textual information. Some message types can create problems during the transmission. To avoid this problem, HDLC uses a process called bit stuffing. So in the bit stuffing, every time a sender wants to transmit a bit sequence having more than 5 consecutive ones, it inserts one redundant 0 after the 5th one. So here in the data transparency, so using the HDLC frame, we can transfer textual frames or non-textual frames. Suppose if you consider for transmission a message, so you can send a text message, or you can send a voice message, or you can send a video message, or you can send a document, or you can send an animation, or you can send a context. So you can transmit. You are sending different types of messages to the destination, right? So while transmit the different types of messages, some problems may occur in the HDLC. So to avoid that problem, so we are using the bit stuffing concept. So every time a sender wants to transmit a bit sequence having more than 5 consecutive ones, it inserts one redundant 0 after the 5th one. So why we are using this concept means, so in the frame format of the HDLC, if you observe, the flag field consists of 0, 6 ones followed by 0, right? So if the information field is again having this same format, then the destination may consider that, so it is the starting and ending of the frame, and it will discard the remaining frames, right? If this same pattern, that is the 0, 6 ones followed by 0, so if these consecutive ones are there in the information field, so it may consider that it is the it may mismatch that it is the end of the frame. So to avoid this problem, we are using the bit stuffing concept, right? So every time a sender wants to transmit a bit sequence having more than 5 consecutive ones, here it inserts one redundant 0 after the 5th one. If the data field contains a pattern that is the same as sequence reserved for flag field, that is a 0, 6, 1, 0, the receiver interprets the sequence as the ending flag. Okay, so this problem is called as the data transparency, lack of data transparency. So to avoid this problem, we are using the HDLC protocol, the process of a HDLC called bit stuffing. So every time a sender wants to transmit a bit sequence having more than 5 consecutive ones, it inserts one redundant bit, that is 0 after the 5th one. So here we can see the example. The data that we are sending is 000, 7 ones, 00, 5 ones, 0, 1, 000. Okay, so this is the data that we are sending. So according to the bit stuffing method, so we have to add one redundant bit, that is 0 after 5 consecutive ones. So here the sender and the receiver. So the data is sent from sender, that the data is this one, right? So we are inserting the redundant bit 0 after 5 consecutive ones. So here after 5 consecutive ones, so we are stuffing a bit 0. So after that one, 1100, 5 ones. So after the 5 ones, consecutive ones, we are inserting the redundant bit 0. We are stuffing a bit 0 into the data. Okay. So that's why the receiver will consider that. So this is so after 5 consecutive ones, if there is a 0 bit, then it will consider that it is a data path only. So it is not a flag, but it is a data path. Okay. So to avoid the confusion between the flag field and the data path, so we are using the bit stuffing method by inserting an extra bit 0 to the data after the 5 consecutive ones. So this is about the bit stuffing in the HDLC, and thanks for watching my video. Thank you.